So thanks for having me, and thanks for to y'all for tuning in. My name's Kendal. I'm an environmental archaeologist at the University of South Florida, and I find most people don't know really what an archaeologist actually does. So I can clear that up for you. So first, we don't study dinosaurs. So there's that. That's called a paleontologist. And contrary to much popular fiction, we actually spend very little time beating up Nazis, although more and more every day now. But what an archaeologist really does is we study the material record of the human past. So there's a lot of human past. Our species shows up in the fossil record in Africa between 200,000 and 300,000 years ago. And humans start migrating out of Africa just after 100,000 years ago, and pretty quickly spread throughout 6 continents of Earth, which is a lot of space and a lot of time for archaeologists to study. So like most archaeologists, I carve out sort of a small space in space and time to work in. And that just happens to be the Gulf Coast of Florida, mostly the peninsular Gulf Coast. And in respect to time, I work at pre-Columbian Native American village sites, mostly ones that date within the last few thousand years. So the story of Florida is, most of the time, people start it with these guys, Spanish conquistadors De Leon, Narvaez, and De Soto, who show up in La Florida in the 16th century, or the 1500s, if you will. And they're here, you know, looking for mineral wealth and fertile lands, and of course, slave labor to extract all of those things. But really, the story of Florida is much, much older. And it begins with Native Americans, ancient Native Americans, who made their way into the American continents sometime between 20,000 and 15,000 years ago. And really, one piece of Florida trivia that's pretty cool is that some of the earliest human occupied sites in the New World are right here in Florida, actually in sinkhole sites in the Panhandle. And some of those are 15,000 years old, which is pretty crazy. So before I get too far, just some basic definitions. So an artifact is a term archaeologists use all the time. We use it to talk about anything that is made or used or modified by people. So it can be things like pottery, which if you've got me on your screen, I have some examples of some Florida pottery. All of this is about 1,000 to 2,000 years old, common types of Florida pottery. It could also be things like stone tools, right? Like these projectile points from the Gulf Coast of Florida. But artifacts, especially in coastal environments, tend to be made from sort of modified natural materials like bone, these deer bone harpoon points, or these beads made from shark vertebrae. Or another very common artifact are modified marine shells, like this shell cutting tool, or this shell cup. But sometimes some of the best artifacts we find are very simple. They can be things like charcoal from cooking fires, right? Sometimes these are the most valuable artifacts we find in terms of the information they produce. So sometimes, though, we find much larger things in the archaeological record, like house floors with posts still intact from where the supports for the house were, which is something you can see on the left of the PowerPoint there. Or another common feature we'll find are things like ancient cooking pits, where people have had fires for, maintaining heat or cooking food for, a generation or two, and it leaves behind a dense accumulation of burned soil and, refuse from, sloppy cooks and stuff. And that's another very common feature. But on the Gulf Coast, probably the most common archaeological feature you'll find are shell mounds. And these Native Americans started building these in Florida around at least by 5,000 years ago. And they're made mostly from oyster shell or marine snails and fish bones and broken pottery, broken artifacts. And they're piled up. Some of these mounds can be 10 meters tall. Some of them cover very large areas. But so these are the features that I'm most interested in. And as an environmental archaeologist, I studied these shell mounds trying to figure out and track how ancient peoples interacted with surrounding ecosystems. And I end up with complicated questions that sort of force me into bringing together methods from archaeology and from geology and from ecological science. So one of the most important methods for me studying ancient environments is the collection of sediment cores. So these are basically long pipes that we drive into the ground or into the estuary floor, whatever it may be. And the core pipe collects a record of all of the past sediments that have been deposited at that location. And I can use these records, these sediment records, to reconstruct sort of the history of that particular environment in the past. So for example, here are two sediment cores next to each other, photographs. And on the right is sort of an idealized diagram of the sediment record. And these just increase with depth as you go down, right? So we can use these sediments to figure out ancient environments. So for example, the oldest environment in this core record is a beach, which we're all familiar with, hopefully, in Florida. We have lots of those. So this could be a beach or a beach dune type system. The next major layer in this record is intertidal peat from a mangrove forest, right? That developed on top of that beach system. And then on top of the mangroves, we have tons of large shell fragments that were carried there most likely by some sort of storm event or a series of storm events, probably a period of high hurricane activity. And then at the top of the core record, the most recent environment that's there is a seagrass meadow type environment, which is actually what's there today in the coring location. So just by looking at the sediments, we can get a good record of what environments were there in the past. But what also really helps is being able to figure out when some of these major transitions happen. So to do that, archaeologists and geologists as well will use a technique called radiocarbon dating or carbon-14 dating, where to keep it real simple, we send a sample of organic material, it has to be carbon-based material, to a chemistry lab, and they can process it to tell us how old that chunk of carbon is, normally within a range of 20 to 50 years or so. So it's super useful for tracking changes through time. So for example, we have samples sent from this core record, and the best material to send was this mangrove peat because it's full of carbon. It's just decaying trees, right? So the base of the record came back with a date of about 3,000 years ago. And the top came back at about 1,000 years ago. So this tells us, of course, when this mangrove wetland was there, but it also tells us the latest possible date that the sand dune environment was in that location, right? had to be gone by 3,000 years ago. So it's older than that. And it also gives us the youngest possible date for those storm events, right? That shell deposit. Those storms had to occur after 1,000 years ago. And so we can get a lot of information from these carbon dates. So once we have a good paleoenvironmental record, I like to use these to interpret what's going on at coastal archaeological sites. But first, can anyone, hopefully I can hear you, can anyone propose a hypothesis to explain what might be driving these changes in the core record? Anyone have a hypothesis?
You guys can type in the chat box, or if someone wants to unmute, that's fine.
Yeah. It can be even a wild guess.
We've got sea level changes, Kendall.
Yeah, good job. Yeah, that's it. So that is the most, yeah, nicely done. That is the most parsimonious explanation, right? So, and what I would say is the best hypothesis, because at the bottom, what we call this is a transgressive sequence, right? Where sea level is higher and higher in each of these environments. So that is a really good answer. Somebody had their coffee this morning. That's good. All right, so now to the archaeological record. So here I'm showing some excavations we just did last summer at a pre-Columbian village site, shell mound site, actually right next to where those soil cores were taken. And this is what we call an excavation unit, where we dig carefully, level by level, and screen everything to collect all of the cultural material. And here, once we're done with the excavation unit, we end up with what we call a profile, which is basically just the wall of the excavation unit, which we clean up, and we can interpret it much like a core record. So at the base of this profile, we have ancient wind-blown dune sand, right, which dates between 10,000 or even earlier and 3,000 years ago. And after 3,000 years ago, we have a transition to this very dark, organic-rich cultural soil we call midden soil. It's basically just decaying organic remains and shell and pottery and artifacts from basically everyday village life at this site. So now that we have these dates as well, if we put together the core record from the estuary with the excavation unit profile, can anyone sort of generate a hypothesis to explain these changes in the archaeological record? What environmental processes might have been driving this shift? Again, wild guesses are fine, you know.
Kendall, we have weathering and erosion, farming, plant decomposition, the arrival of man.
Yeah, so probably the way I would hypothesize this, that's not bad, is that around 3,000 years ago, we have the development of these large estuarine wetlands in this area, in this general area, which we can tell from the core record, right? That's when those mangrove forests get established. So, and that correlates with the archaeological record with the establishment of sort of intense village life, right? And the development of these organic soils from the decomposition of you know, organic remains. So my hypothesis would be that increased estuary productivity from the establishment of estuary wetlands made this a very attractive environment for ancient Native American peoples and made this a really good place to set up a large village site, right? So it's just kind of a basic correlation hypothesis that we could then investigate with more data that we have from the cores and from the excavations. But so this is just sort of a basic idea to give you a notion of how environmental archaeologists think in Florida. And sort of finally, I wanted to plug a great organization that might represent a good resource for y'all. The Florida Public Archaeology Network, which is a state organization staffed by archaeologists and archaeological scientists. And they mostly do outreach and education work. They travel and do demonstrations and teach-ins and field trips and events and that sort of thing. And they are doing a lot of virtual stuff, of course, these days. But I wanted to put this up since they're such a great resource for education. And then just finally, I wanted to give you my contact information, my email if you have any questions or whatever. And then if you want to follow any of my lab's field research in Tampa Bay, the best way to do that is on our Instagram account, which is right there for you, Ancient Tampa Bay. But anyway, thank you all for listening, and thanks to Brian and Stephanie for having me.